Hi, I'm Martin Warwick. We are at the Small Cells World Summit 2014 here in Docklands XL in London, and I'm talking with Mike Schabel, who is the VP of the Small Cells Wireless Division at Alcatel-Lucent. Mike, what factors are driving mobile network demand for small cells?
I think it's important to understand that small cells is a very broad area. We have residential, we have enterprise, indoor, cellular coverage, and we have metro cells. In fact, those three segments have very different drivers underneath it, but all of the points are very common in the sense that they're looking for providing an extraordinary user experience, an ultra broadband wireless IP experience everywhere you go. So whether I'm outdoors in the middle of a dense urban area, I'm out on the docks here in London, or I'm in my home, I think operators would like to provide that type of experience for you. Delivering that is very interesting because each of those three segments have very different go-to-market challenges and strategies, and so it's not so easy to have one snap and we've covered the full base. But that's the objective, and that's what drives small cells today.
Let's look on the obverse of the coin. What do you think are the key challenges, the problems that are being faced by telcos as they begin to deploy and implement small cell solutions?
The biggest problem, I would say, that we're all dealing with is the fact that it's new. And so we have to think on our whiteboards and scratch out the plans of how we're going to be successful in deploying metro cells outdoors, not just on towers, which we've done for many years on macro, but on lampposts and signposts and the building facades. And that's just a different ecosystem of partners that we've been dealing with. In the indoor environment, it's new because wireless operators have been selling contracts, mobile contracts, to enterprise customers for a very long time, but now we have to sell infrastructure inside of those buildings. And we've done that in the past with what's called distributed antenna systems to some degree, but now as we talk about a very large domain of venues, we have to go and sell that infrastructure into a much broader set of building owners and landowners, and that's just new and different.
Do you think small cell technology is actually capable of delivering telco requirements now, as of this moment, or does the technology need more development?
Today we're delivering small cells with macro-like KPIs. With the handoffs and handouts and hand-ins and all the mobility and the performance that we would expect from the macro, we're delivering with small cells, and in fact, actually, we're improving the overall performance of the network. The macro gets better when we introduce small cells, interestingly enough. Is more development required? Absolutely, and it speaks to how fast we can optimize the network in order to achieve that. So there's a bit of intelligent work that's going on to achieve that level of performance, and now it's just a matter of optimizing it, and that's where the development is focused on with small cells today.
And how does small cells for 4G and beyond fit in with the move towards NFV, Network Functions Virtualization?
I would say we're talking about perhaps two slightly different things, and so what I'm going to do is say that the small cell is really about the last mile access point for wireless delivery of an IP broadband experience. Network function virtualization, NFV, is about taking the call processing functions in the network and, to the extent that is appropriate, virtualizing them. What we're finding is that many of the functions that are living at the access point belong at the access point. This is the most pragmatic and efficient way from a network architecture perspective to deploy those functions. What we're finding is a lot of the control-like functions that exist inside of the network end up getting virtualized. And in that sense, the interface is standard between the two. So I would say the big network is what's getting moved into NFV. What the next step is, which is really interesting, is the evolution into cloud-based architectures. And there I think there's some really cool things we can do to take some of the processing that's on the access point and move that into a virtualized environment. But I think the access point will largely look the same, it's just moving a couple of things around.
What role do you see for small cells beyond 4G and into future 5G networks?
So I think as we speak about 5G and who knows, 6G, 7G, 8G, who knows? hopefully in our lifetime. So we're going to start experiencing a more blended, converged experience for delivering content to you as a user, anytime, anywhere, using all of the available facilities that we have. Whether it's a Wi-Fi network, whether it's a macro network, whether it's a small cell network, to deliver that content intelligently and using, let's say, load balancing across all of those layers. I think what we'll find is that there's no new super speed code that's going to be implemented, but rather it's leveraging all those facilities. And in that context, we find that small cells are delivering something that is fundamental. To scale the network to achieve the 30x, 100x, 1000x type deliveries of growth of broadband IP that we've been talking about, we absolutely fundamentally need small cells. They're going to be in that equation, and now the question is, now the network needs to make decisions about how it uses those different access points, the macro, the small cell, to deliver that content to you. I think that's where the future is going.
Mike Schabel, thank you.
Happy to be here, thank you.